Here are some details on 5G parameters. Frequency bands. 5G operates in several frequency bands, including low band, mid band, and high band, also known as millimeter wave. Low band frequencies provide wider coverage, while high band frequencies offer greater capacity and faster data speeds. Mid-band frequencies provide a balance between coverage and capacity. Modulation and coding schemes. 5G uses advanced modulation and coding schemes, including 256 QAM and LDPC, to increase data transfer rates and improve spectral efficiency. These schemes allow more data to be transmitted per unit of time, which is essential for supporting high-bandwidth applications like 4K video streaming and virtual reality. Multiple access technologies. 5G uses several multiple access technologies, including orthogonal frequency division multiple access, OFDMA, and single carrier frequency division multiple access, SC-FDMA, to manage multiple connections simultaneously. These technologies allow multiple devices to share the same frequency band without causing interference, improving overall network capacity and performance. Massive MIMO. 5G uses massive MIMO, multiple input multiple output, technology, which involves using multiple antennas at the base station and the device to improve network capacity and coverage. Massive MIMO allows the network to serve multiple users simultaneously and improve the quality of service for each user. Network slicing. 5G uses network slicing to allocate network resources dynamically based on application requirements. Network slicing involves creating virtualized network segments that can be optimized for different use cases, such as ultra-reliable low-latency communications, ULC, or massive machine-type communications, MMTC. Latency. 5G has significantly lower latency than previous generations of cellular technology, thanks to advanced features like edge computing and network slicing. Lower latency is essential for supporting applications that require real-time response, such as autonomous vehicles and industrial automation. Security. 5G includes several security features, including end-to-end encryption, device authentication, and network slicing. These features help to protect users and data from cyber threats and ensure the integrity and confidentiality of network traffic. Overall, 5G represents a significant advancement in cellular technology, with higher data transfer rates, lower latency, and improved network capacity and coverage. As with previous generations of cellular technology, cellular telecommunication companies will need to optimize 5G network performance using advanced monitoring and optimization tools and implement solutions to address performance issues as they arise. 5G's network problems and how cellular telecommunications companies can optimize them. As with any new technology, 5G networks have their own set of challenges that cellular telecommunication companies need to address in order to optimize network performance. Here are some of the main 5G network problems and potential optimization strategies. 1. Interference and propagation loss. 5G operates at high frequencies, which are more prone to interference and propagation loss than lower frequencies. 1. This can lead to reduced coverage and poor signal quality, particularly in urban environments with lots of obstacles. Optimization strategies. Cellular telecommunication companies can optimize 5G network performance by deploying small cells, which are low-powered cellular access points that can be placed in urban areas to increase coverage and capacity. Additionally, beamforming technology can be used to direct signals towards specific users or areas, reducing interference and propagation loss. 1. Network congestion. As more devices connect to 5G networks, network congestion can become a problem, leading to slower data transfer rates and reduced network capacity. Optimization strategies. To optimize 5G network performance, cellular telecommunication companies can implement dynamic spectrum sharing, which allows the network to allocate resources more efficiently based on demand. Additionally, network slicing can be used to create dedicated virtualized network segments for high-priority applications, ensuring that they receive the necessary resources. 1. Security and privacy. 5G networks are vulnerable to a variety of security threats, including cyberattacks and data breaches. 1. Ensuring the security and privacy of network traffic is essential for protecting users and their data. Optimization strategies. To optimize 5G network performance, Cellular telecommunication companies can implement end-to-end encryption, device authentication, and other security features to protect network traffic from cyber threats. Additionally, implementing privacy-preserving technologies like differential privacy can help to protect user data while still allowing for network optimization. 1. Infrastructure and deployment costs. Deploying 5G networks requires significant infrastructure investment, including upgrading existing cell towers and building new ones. 1. This can be a costly process, particularly in areas with challenging terrain or limited access to power and internet infrastructure. Optimization strategies. To optimize 5G network performance, cellular telecommunication companies can explore alternative deployment models, such as shared infrastructure or using drones to deploy small cells in hard-to-reach areas. Additionally, implementing energy-efficient technologies like solar power and battery backup can help to reduce infrastructure costs and ensure reliable network performance. 1. Integration with existing networks. 5G networks need to integrate with existing 4G and 3G networks to ensure seamless connectivity for users. 1. This can be a complex process, particularly when it comes to managing handovers between different network types. Optimization strategies. To optimize 5G network performance, cellular telecommunication companies can implement advanced handover algorithms and network planning tools to ensure seamless connectivity between different network types. Additionally, implementing advanced network orchestration tools can help to automate network management tasks and optimize network performance. Overall, optimizing 5G network performance will require a combination of advanced technologies, strategic planning, and ongoing monitoring and optimization. By implementing the right strategies and tools, cellular telecommunication companies can ensure that 5G networks deliver the high-speed, low-latency connectivity that users expect. To optimize the performance of 5G networks and solve any potential problems, cellular telecommunication companies can take several steps, including deploying more base stations. 5G networks rely on high-frequency radio waves that have a shorter range than the lower-frequency waves used in 4G networks. This means that more base stations are needed to provide coverage, particularly in densely populated areas. Cellular companies can optimize 5G performance by increasing the number of base stations, particularly in urban areas. Implementing network slicing. Network slicing is a technique that allows cellular companies to create multiple virtual networks that can be optimized for specific use cases or industries. By using network slicing, cellular companies can ensure that each virtual network is optimized for the specific needs of its users, ensuring optimal performance and reliability. Using advanced antennas, 5G networks use a new type of antenna called a massive MIMO antenna. These antennas use multiple antennas to transmit and receive data simultaneously, which can improve network performance and increase capacity. Cellular companies can optimize 5G performance by deploying advanced antennas, particularly in areas with high user density. Optimizing network architecture. 5G networks are designed to be more flexible and adaptable than previous generations of cellular networks. Cellular companies can optimize 5G performance by designing their network architecture to be more efficient and scalable. This may involve using edge computing to reduce latency, increase data processing speeds, or implementing software-defined networking (SDN) to automate network management and optimization. Implementing network function virtualization. Network function virtualization (NFV) is a technology that allows cellular companies to virtualize network functions that were previously performed by specialized hardware. This can improve network efficiency and reduce costs. By implementing NFV, cellular companies can optimize 5G performance by reducing the need for specialized hardware and improving the scalability and flexibility of their networks. Addressing security concerns. With the increased connectivity and data transmission speeds of 5G networks, security concerns become more important. Cellular companies can optimize 5G performance by addressing security concerns by implementing end-to-end encryption, implementing security protocols like Transport Layer Security, TLS, and Secure Sockets Layer, SSL, and implementing security measures such as intrusion detection and prevention systems. Overall, the key to optimizing 5G network performance is to design networks that are scalable, efficient, and secure. Cellular companies can achieve this by deploying more base stations, using advanced antennas, implementing network slicing and function virtualization, optimizing network architecture, and addressing security concerns.